Okay, so as I mentioned, biotransformation can metabolize endogenous or exogenous toxins. Here's an endogenous toxin. This is bilirubin. This word. Bilirubin. You go to the hospital, you have some serious blood problem. They're going to check your blood. One of the most important things they're going to look for is bilirubin. Bilirubin is the breakdown product of hemoglobin. So as hemoglobin is broken down in the red blood cells naturally, it'll produce bilirubin when the protein is actually broken up. Normal destruction of red blood cells, they're initially biotransformed to bilirubin. But bilirubin is toxic, and especially for newborns, it's extremely toxic for brains of newborns. So we can make this bilirubin, this thing, and this looks like, you can sort of see this. What is this? It's a ring that was broken up. Can you see what the ring was? This is heme. This is the porphyrin ring. These are the four nitrogen groups and the 2 carboxylic acid groups. So this is bilirubin is the direct breakdown of heme. So we want to get rid of this stuff. It's toxic, and so we'll make this toxic bilirubin created naturally inside the body into a water-soluble metabolite. So it's excreted into the bile, eliminated in the feces. Here's an exobiotic transformation. The biotransformation can do, this is an example of endogenous and exogenous. And this is the PCDF that we were talking about, I was just talking about. Polychlorinated diphenyls, and then this is polychlorinated dibenzofuran, PCDF conjugates, indicating chlorine is on both sides of this ring, any number, any configuration. So this is a PCDF. So I guess the point here is that both of these are transformed into substances which are more soluble by this enzyme system called biotransformation. And as we said, they're both lipophilic, so they become more water soluble with time and then excreted. And here's another thing, because the lipophilic compounds are more toxic, the aqueous compounds are less toxic. Biotransformation not really required for the aqueous compounds, so the compounds which do this partition in favor of the aqueous phase. In other words, xenobiotics that have a high water to oil partition ratio, more aqueous. Those are excreted rapidly, not really necessary to biotransform those. So those are less likely candidates for biotransformation. As I said, biotransformation not perfect. Most of the things it does well, it makes lipophilic substances more hydrophilic and they're excreted, but sometimes it does the reverse. It makes a non-toxic chemical into something very toxic. So this is the example. This is vinyl chloride, which is converted in the body to, what is this? This 3-membered ring with an oxygen. It's called an epoxide, yeah. So in both cases, we've gone in the right direction, but it resulted in a bad thing. And so this vinyl group or vinyl chloride, either one of these, oxygenized by or oxidized by alkene monooxygenase. If we're taking this very hydrophobic substance and adding oxygen, we're making it more polar. So we're going in the right direction. We're going toward more hydrophilic. But unfortunately, it's taken us down a toxic path because now it's more highly oxidized. In fact, it is more water soluble, but it's also extremely reactive. Epoxide is extremely reactive, and it will react with almost anything. It reacts with the DNA. And so you've got something really nasty vinyl chloride to begin with, and you've made it even nastier. So it's not perfect. It's not a perfect system. Sometimes it gets tricked into making things more toxic when it's trying to make things less toxic. So this is bioactivation. So in fact, biotransformation can do two things: make things less toxic or make things more toxic. Making things less toxic is detoxification. Making things more toxic is bioactivation. Yeah, here's a nice little encyclopedia of compounds that are converted to toxic compounds, made more toxic. In other words, bioactivated during metabolism or during biotransformation. Acetaminophen, you know what this is? Take this for headaches, but if you take too much, it will kill your liver. Right? So we only have a certain ability to detoxify this. When we get above that upper limit, we'll talk about this more later in terms of biochemistry. Get above that upper limit, and then it becomes extremely toxic. 2-acetylminofluorine, there's aflatoxin B1, the one we were just talking about. Benzoapyrene, also bioactivated. Carbon tetrachloride. That's a nitrosamine. I don't have an example of that molecule. So nitrosamines in general, bioactivated. Here's another picture of our new favorite enzyme, P450. Not a very good picture. So we can categorize these reactions, all these biotransformation reactions, according to the type of reaction they do. And they're classified in general as phase 1 and phase 2 reactions. Phase 1, modify the chemical. So it's a PCDF or PCB. So modify it by adding some functional group. Basically, what it does here is it's trying to make the chemical more water soluble. So generally, we're adding some polar group to the chemical as part of phase 1 enzymes. And then the phase 1 enzymes feed into the phase 2 enzymes. So after this system is finished making the chemical more polar, ways we just saw, adding oxygen, the chemical will then go to phase 2 in some cases. In phase 2, we're not oxidizing. What we're doing is we're putting molecules together. So we're connecting the xenobiotic that's oxidized, connecting it onto some other molecule, which makes it easier to excrete. This process is called conjugation. We use this word a lot in chemistry. I use it mostly to describe single double bonds. That's a conjugated double bond system. Conjugated also means just coming together to form a union. Yeah, so this is what I just said. Benzene, for example, is a xenobiotic that would come in. It could be transformed by the phase 1 enzymes into something more hydrophilic. So phenol is a lot more water soluble than benzene. Still very toxic. And so the phase 2 enzymes will actually connect this oxidized part of the xenobiotic with some functional group. And this is just one of the many. So in this case, it connects it to sulfate. That makes this even more water soluble. Sulfate now has a minus charge. So basically an acid group. So phase 1 oxidizes, phase 2 conjugates.